Okay, let's talk about types of data. As I like to do in these talks, I want you to think beyond the actual activity you're doing. You've done the activities, so that's great, right? And you've learned something. But now I'm here, and that's why I'm the professor, is to put that into some perspective. Okay, so I like to think of things as problem solving, right? That's what we do in the world. We problem solving on the individual level, the community level, the national level, the international level. All right? We human beings being alive is a struggle, but I think it's a beautiful struggle, and part of it is collective problem solving. What kind of mental categories do we use to plan for these problems? How do we do that? So, number one rule is we have to know what the problem is. There's a lot of arguments over that, right? We have people that are on the left politically and right politically, and sometimes they want the same things, but the way that they want to get there is very different. So this is where we have our ideological divisions. So the number one rule of solving a problem is knowing what the problem is. And that's where data types come in, right? Depending on what we're observing, it has a different character or nature that we can empirically take in with our five senses, observe. So, depending on how we understand data is going to help us solve the problem properly. So this we have to start out, right? So when you go onto a car to drive it, right, you check the seat, right? You make sure the car is in park. You see if you got gas in the tank. You check the mirrors, right? These are all things you do before you start driving the car, and then you might turn the key. Similarly, we got to check the data type before we do anything about it, because that's going to guide us on what we do next, how we solve that problem, no matter what kind of question we are asking. So what I want you to think about is three types of distinctions. Okay, that other video covered discrete and continuous, and quantitative versus qualitative, and there's this other one that I briefly want to go over. But discrete, right, means separate, right? There's sharp divisions between things. The way that I always think about this is states are discrete, countries are discrete, at least on a map, right? We can make some kind of argument that these are human boundaries and animals cross over them and they're socially constructed, which is true, but they are, they are like semi-permanent and they are discrete. So you can go from Nevada into California. You can go from New York into New Jersey. There is a line there, and they are separate things. This discrete nature means that they are separate. Continuous is different. Continuous is elevation, is temperature, right? It's constantly around us, right? There's a temperature everywhere in this room and everywhere around the world. It's this measurement of how quickly molecules are moving. Elevation, same thing. It's continuous, right? It's constantly part of one thing that's going up and down. Where discrete is one over here, and one over here, right? These pins on these maps are discrete. They're in some places and not others. But this blue surface, which is the ocean, is continuous, right? So just keep on coming up with metaphors, listening to videos, things like that. The more examples you have are better, but I want you to know that distinction. We have quantitative versus qualitative. Quantitative is less or more. That's it. Can you say something is more or less than another one? Is there a scale to measure it on? Okay, so I always think about height, weight, grade, point average, things like that. We can say something is definitively more or less on a scale. Okay? Qualitative just means like the states. There's differences, right? We can't inherently tell. There's no scale to say that like Nevada and California is more or less. If we were saying surface area or population, those are quantitative. But just the states themselves are in different categories. We say those are qualitative. Apples versus oranges. Different kinds, qualities, or types. That's qualitative. Now within quantitative data, we have ordinal versus ratio data. These both count, but the difference is that ordinal data, we don't know the magnitude of difference between them. All right. So the way I always like to think about this is, at the time of this, the Sixers aren't doing so great. So the Sixers are in 5th place, and Indiana is in 4th place, and Celtics are in 3rd place. What I'm telling you is that the Celtics are ranked higher than the Sixers right now, but we don't know by how much. Ordinal is a way of expressing quantitative difference without a magnitude of difference. Yep. And then when we get to ratio data, we know by how much. So Philadelphia is 2 hours from New York, and it's, I don't know. Let's see. Here's another place. How about this? New York is 5 hours to Boston and 2 hours to Philadelphia. We know that Boston is 3 more hours away from New York than Philadelphia. So what does that tell us? It says that we have an order of magnitude. We have more information. We can say Boston is further from New York than Philadelphia. Okay, and we know by how much. With ordinal, we don't know by how much. So those 3 distinctions, check it, get some examples, plenty of videos. You know you got this.